Okay, so we've got an example here about using a constant acceleration formulae. So we've got a particle moves in a straight line from A to B with constant deceleration 1.5 meters per second squared. The velocity is 8 meters per second at A and 2 meters per second at B. Find the time taken to move from A to B and the distance from A to B. The particle continues to point at C, arriving 6 seconds after leaving A. Find the velocity of the particle at C and then the distance from A to C. Okay, so first thing we've got to do, start jotting down the things that we know. So in this top section here, we're told that the deceleration is 1.5 meters per second squared. So the acceleration is minus 1.5 meters per second squared. So deceleration is slowing down, so the acceleration itself is negative. We've got initial velocity, u is 8 meters per second. And then the final velocity is 2 meters per second. So we've got A, U, and V. Part A, we're trying to find what T is from those three things. So we've got A, U, V, and we're trying to find T. The equation that connects those four things is V equals U plus AT. And then we can just substitute in the values that we have. So V is 2, U is 8, A is minus 1.5, and then T is what we're trying to find. And then we can just rearrange that. So 1.5T equals 6. So therefore T is 4 seconds. Part B, it's going to be the same kind of idea. This time we're trying to find what S is. And so we're trying to find S, again, from these three things we've got up here. So the equation that connects those is S equals UT, add a half AT squared. So I'm using the value T here rather than the value V. I don't know why I did that. But anyway, we can do it anyway. Because we've got T, we've got U up here, and we've got A from here. So if we substitute in, we're going to get 8 times 4 plus a half times minus 1.5 times by 4 squared, and then we just need to calculate what it is, which is 20 meters. So we could also have used the formula V squared equals U squared plus 2AS as well, in fact. So we could have used these three things here to find what S is and then rearrange them there. Anyway, there we go. Final part of the question then. So we've got a particle continues to point C, arriving 6 seconds after leaving A. And then we've got two more things to find. So in part C, we've got a different setup now. So we've still got the same initial velocity, which is the 8 meters per second. We've still got an acceleration of minus 1.5 meters per second squared. This time we're told what T is, which is 6 seconds. So the velocity of the particle at C, we want an equation that connects these three things. That is V equals U plus AT. So we can just substitute into that. So we're going to 8 take 1.5 times by 6. And that is going to come to minus 1 meters per second. So the minus is important. The minus means that it's actually starting to head back to where it came from. In part D, the distance from A to C, we've got to do S, is what we're trying to find. Then we can use the equation S equals UT, add a half AT squared with these values from here. So we're going to get 8 times 6 plus a half times minus 1.5 times 6 squared. And all we need to do is calculate that. That comes to 21 meters. There we have it.